took an example with some question. A CRV is uniformly distributed in the interval 0 to 10. Sketch the PDF and following question. A part, less than 3. B part, probability is greater than 9. And C part, probability is in between 4 to 8. We can draw CDF graph here up to 10. Height is 1 by 10. PDF, probability density function for uniform distributed in the range of 0 to 10. First I want to calculate probability, so I apply formula for this function. Mathematical expression is 1 by 10 for the range of 0 to 10, otherwise 0. This is the definition of UDF, uniform density function. 1 by 10 dx, 1 by 10 x 0 to 3. By putting value we get 3 by 10, 0.3. One more idea, mark 3 here and calculate area by height into width. 1 by 10 into 0.3, sorry 3. No point there, only 3 there. Only 3 there, answer will be 0.3. 3. In second question we have to calculate area above 9. I mark 9 here, above area 9 is 0.1, 0.1 into 10, 1 by 0.1, or 1 into 1 by 10 is 0.1. For area 4 to 8, 4 to 8, this much area, 4 into 1 by 10 equals to 0.4. For UDF we solve a particular question. Exponential density function. An exponential density function, fx is denoted as bx 0. I draw PDF of it. This function to be a PDF, relation for that is integration fx dx should be 1. 0 to infinite a power minus bx dx equals to 1. A upon b e power minus bx, 0 to infinite a upon b equals to 1. A equals to b. If a and b both are equal, then exponential density function is a probability density function. Means we can write in this way, e power minus bx or a e power minus ax. Both are valid. Ux multiply with ux. Both are valid density function. If someone told us 5 e power minus 10x, this is a valid exponential density function because both values should be same. In this case, not same, it is not valid exponential density function. Next is Laplacian density function. Laplacian density function. For Laplacian density function, fx is a minus infinite to infinite. This term, mod term, can be further solved by considering a greater x is greater than 0 and x is less than 0. In both cases, this is the PDF for us. Modulus curve is always symmetrical about origin. It is even symmetric function, always symmetrical about origin. To make it this is PDF, we have to solve this integration. If we solve these two terms, limit is now squeezed due to this. It is minus infinite converted to 0, and second portion limit is minus infinite to 0 e power bx dx. By solution of this, a by b equals to 1. This should be 1. 2a upon b equals to 1, a equals to b by 2. If it is true, then it is a valid PDF. Now we will discuss 2005 gate question. Question is, a PDF is shown to us. I draw. In this question, PDF is given to us. We want to find out relation between A and B. X is greater than half and CDF. Relation between A and B come from this formula, fx dx. Area should be 1. Area we can calculate from this idea also. Base into height. Base is 2a into height is b into half equals to 1. AB should be 1 in short way. Otherwise we have to define fx. What is the definition of fx is? Definition of fx is minus b by a x plus b. B is this point when x is greater than 0, less than 0, plus b. Now fx is defined minus b by a mod x plus b. We put into the formula and get ab equals to 1. In second case, x is greater than a by 2. In same case, we have to calculate area from this to this fx dx. We have to calculate up to infinite. From a to infinite, no value exists, so we put a here. If we calculate area from a by 2 to a, we can calculate it is a triangle half base into height. Base is a by 2, height. What is the height? Height come from this expression for positive direction. We get the height. If I put a by 2 in it, we got the value is b by 2. This is a straight line expression. I put a by 2 plus b equals to b by 2. AB by 8. AB by 8. What is the value of AB is 1. The complete area is 1 by 8. Now CDF. CDF is very important portion of this question. Actually 2 marks question in gate to term 5 is CDF1. For calculation of CDF, we have to put this formula minus a to x fx dx. For application of this formula, I segregate two portion. Fx is defined for this and this, different value. Greater than this, greater than 0 is, less than 0 is, I put segregated value. Now we discuss greater than 0 के लिए डिस्कस किया जा रहा है. कैसे किया जाए? Sorry, we first discuss for less than 0. Minus a to 0 minus a to x b upon ax plus b dx. We first solve this integration. Bx square by 2 plus bx, put value minus a to x. We can define function in tau term and putting the value in x term. By putting value, we get this solution. Make this solution in parabolic pattern. Because we have PDF is ramp type structure, straight line, means our CDF should be in square term, parabolic pattern. To make it parabolic, 2a x plus a का whole square. ये है CDF for less than 0. For greater than 0, we took next page minus a to x fx dx. For x greater than 0, we want to find out. For x greater than 0, we have to first integrate from minus a to 0 and then 0 to x, because at 0 where the definition of fx is changed, so we have to bifurcate these two limits in this way so that we can calculate this term dx. By this calculation, we found AB by 2. And second calculation, for second integration, solution of second integration, we find b by a x square by 2 plus bx. By rearranging and making it a parabola, a x minus a का whole square, means we have two solutions regarding CDF of given function is b upon 2a x plus a whole square x minus a whole square 2a ab 0. Now CDF is for given, we can draw in this way. For negative, put value at minus a location, it is 0. At 0 location, it is ab by 2, means half. It is parabolic pattern. Parabola is located at minus a location. This is again a parabola. This type of parabola located at a location, but difference is it is subtract from 1, means just subtract from 1. complete parabola is subtract from 1 means mirror image of it is, assume this one line is mirror and draw a mirror image. Combination of these two is our result, CDF of it. Now we will discuss a new topic, function of one variable, one random variable, a random variable gx is given to us, y equals to gx. Y is another random variable. Transform x is transformed into y with some idea z. Probability for y, capital Y, small y, gx less than y. Then we calculate in we can calculate x is element of dy. We calculate new limit of it. One more thing, fy of y, py, capital Y less than y, p gx y, then again this x element of dy. For this we can if x is CRV, continuous random variable, then PDF of fx of x is given, fx of y is calculated from this formula. We can calculate from this formula. Sorry, CDF can be calculated from this formula. By integration, limit is changed now. We can determine, this is the first case, A case. In this case, PDF of x is given, we calculate direct CDF of new variable in this way. Integration limit is changed. If we want to calculate y PDF, capital Y, random variable capital Y, PDF is, we can calculate with two cases. We can calculate PDF of y with the help of two ideas. First is fy of y, fx hy dh by dy, or fx hy upon g dash x mod fy of y, where x is g inverse y equals to hy. This term come from where y equals to g x is 1-to-1 correspondence, 1-to-1, and its inverse is possible. 1-to-1 correspondence, then we put new value of y into x and differentiate by g dash x. We directly find PDF of new parameter. If it is not 1-to-1 correspondence, then we can calculate fy is not 1-to-1, then y equals to gx by xk is roots of y. then fy of y k fx xk g dash xk. If some function have two roots, means two different value added for root location, and g dash x divided with that value with mod function. These three formula we can apply in this question. I take a question, simple question. Y equals to 2x plus 3, capital X plus 3, if a RV is uniformly distributed in -1 to 2. We want to calculate fy of y with the formulas. Fx is given to us is Fx is uniformly distributed between -1 to 2, -1 to 2. Height of this area should be covered is 1, then height of it 1 by 3. Fx is defined in this way, and with the help of the formula y equals to gx equals to 2x plus 3, our formula is fy of y fx hy upon g dash x. In this question, g dash is defined in this way. The g dash x is 2. Solve this expression is solved for x equals to y minus 3 upon 2. Put this value into the expression. In this expression, 1 by 3 y minus 3 by 2 2 and minus 1 I put, otherwise 0. By putting this value, new definition of fx is 1 by 3, range is revised range is -2 y minus 3 4 1 to 7 is the range, otherwise for the range value is 1 by 3. So and gx is 2. Then I directly write expression for fy of y is 1 by 3 dot 1 by 2 due to g dash x in the range of 1 to 7, otherwise 0. This is the final PDF for given function. If we want CDF for that, CDF can be easily calculated from this question. Fx dx, this limit range is revised dy. If we put revised limit rate in it, then we will get result. Revised limit range is put into the formula fy of y minus 3 upon 6 plus 1 by 3. We solve y minus 1 upon 6. Fy we can solve in this way. This range start from -1 as per question range given to us. X is now new value of, because dy we have to put here. By putting this value we get the result minus sign here. Everything is correct. Two identical distributed zero mean random variable u and v given to us. Two identical distributed zero mean random variable given to us, minus a and a, height is 1 upon 2a. Same type of random variable, zero mean, we mark here. both PDF and CDF is given to us, fx and gx come from 2v, PDF of 2v. So now we calculate first PDF of first case. PDF of first case, fx come from, because its PDF is given in this way, 1 upon 2a, x vary between minus a to a, otherwise 0. We put this function value into this formula, fx of x minus infinite to x fx dx minus a to x 1 upon 2a dx x 2a x and minus a x plus a upon 2a. Fx is given to us is x plus a upon 2a. For double of it means limit is change. How limit is change? 2v equals to x, v equals to x by 2. Newly revised limit is x by 2. From minus a to x by 2, I directly put function fx dx gx, PDF of second one. Once I put then minus a to x by 2 fx, value of fx is 1 upon 2a by solve this integration, x by 2a plus a upon 2a, x plus 2a upon 4a, value of gx. Then we draw these two diagram for selecting the given option. Choose the correct option. We have to search out for correct option by eliminating the remaining option. First we find fx is x plus a upon 2a, gx is x plus 2a upon 4a. I want to draw, I put minus a, then x is 0, I put 0, 1 upon 2a, I put x equals to 0, its value is half, and I put x equals to plus a, its value is completely 1. In second case gx x plus 2a upon 4a, its range is revised, I put here minus 2a. In the case of minus 2a, value 0, I put 0 here, x equals to at a half again, and that put 2a 1, gx in red, fx in black. Now choosing the correct option. First option, fx minus gx is always positive. In the positive half, fx is greater. In negative half, gx is greater. This is not correct. fx minus fx minus gx less than 0 is also not correct, because in both condition different answer. If you multiply with x, it is always positive or negative. In this region x is positive, fx minus gx is positive, so answer is positive for this region. Fx minus gx is negative, x is negative, both are negative, means multiplication of these two is positive, means this option is correct when x is multiplied with this condition. That's all. This is very important question. In the question paper, we have to find out the right answer by eliminating the remaining option available to us by drawing this diagram. By drawing, we are surely confirm about what is the exact answer is. Now, characteristic of random variable, mean value. We already this topic discussed with maths. Fxi for discrete case drv. If it is continuous, mu is come from expectation. Mu is also known as expectation. It's come from x fx dx. DC component. For communication point of view, this term is very useful. Second is mean square value. Square fx I equals to 1 to m for drv. For crv, I write this equation once again. Ex square for continuous x square fx dx. This is known as, this is in the CRV domain, total power, known as m2 also. Mean value is known as m1 also. Move to next page. Third, variance. Variance is represented by square m2 minus m1 square. Mean square value square mean value square of mean known as AC power, which is very useful in communication. Standard deviation, root of variance, sigma m2 minus m1 square. RMS value of AC component RMS value. We jot down all the formulas and now we discuss some great question.